Chapter number 1, Modeling of First Order Linear Differential Equations. What is the meaning of modeling when we come into engineering or physics? The answer has to be given in the next section. But before that, we have to understand some of the important concepts about the differential equations that are of the use for the future sections. So let me begin our first section, a review of differential equations. What is a differential equation? A mathematical equation that involves the derivatives of the unknown function is called the differential equation. So, a differential equation is simply an equation in which there appear the derivatives of the unknown function. There are two main categories of the differential equations. First one is ordinary differential equations. And in the short form we write them as ODEs. And the second one is partial differential equations. In short form we write them as PDEs. A main difference between an ordinary differential equation and a partial differential equation is that in the case of an ordinary differential equation, the unknown function is the function of only one independent variable, while in the case of a partial differential equation, the unknown function is the function of more than one independent variables. So, for example, in the case of an ordinary differential equation, let the unknown function be y. Then it is the function of only one variable, x. And since the unknown function is the function of only one variable, therefore the derivatives that will appear in an ordinary differential equation are the total derivatives, not the partial derivatives. Similarly, if we choose x, y and z, three independent variables, then the unknown function for the case of a partial differential equation is u, and u is the function of three independent variables. And the derivatives that will involve in a partial differential equation are the partial derivatives. For now I will give you some of the examples of ordinary differential equations and partial differential equations. First example is dy by dx, first derivative of y with respect to x is equal to cos x. Second one is x d square y by dx square plus 5y is equal to e raised to the power x. Third is d cube y by dx cube, third derivative of y with respect to x, plus 9y square is equal to sin x dy by dx. So these all three are the examples of the ordinary differential equation, because the derivatives that are involving in these equations are the total derivatives, not the partial derivatives. Similarly, in the case of partial differential equation, the examples are: number 1, partial square u by partial x square plus partial square u by partial y square plus partial square u by partial z square is equal to 0. This is called the three-dimensional Laplace's equation. There are more examples. For example, 5 partial square u by partial x square is equal to 6 partial u by partial t, etc., and so on. These are the examples of partial differential equations. Since in this chapter we are learning the first order linear differential equations, so we will restrict ourselves to ordinary differential equations, not the partial differential equations. Next term that we will learn is the order of a given differential equation. The order of a given differential equation is the order of the highest order derivative appearing in the differential equation. So we will write the order of a differential equation is the order of highest order derivative appearing in a given differential equation. In our differential equation dE. So for example, in the first example, the order is 1 because there is only one derivative involving in this equation, dy by dx, and its order is 1. Therefore the order of this differential equation is 1. So this differential equation is called the first order differential equation. Number 2, here is the only one derivative appearing and its order is 2. This is second order derivative, therefore the order of this equation is 2, and this is second order differential equation. Similarly, there are two derivatives involving in this equation, and the highest order derivative is the third order derivative, and therefore order of this equation is 3. So this is third order differential equation. Similarly, an nth order ordinary differential equation is one in which the highest order derivative has the order n. The next concept is the linearity. Linear ordinary differential equation. A linear differential equation has following three properties. Number 1, the unknown function is linear. So what is not allowed is any power of y other than 1. For example, y square, y raised to the power 5, and so on. These are not allowed. Similarly, transcendental functions of y are not allowed. For example, sin y, since it is not linear because its waveform is like this, which is absolutely not a linear graph. Cos y, tan y, all of the trigonometric functions are not allowed. Hyperbolic functions are not allowed. Inverse hyperbolic functions are not allowed. Similarly, e raised to the power y, exponential functions, logarithmic functions, ln of y, such types of functions of y are not allowed because they are not linear functions. The second condition is that there should be only first degree derivatives in the differential equation. First degree derivatives. So what is not allowed? Any whole power of the derivatives other than 1. For example, d square y by dx square whole power 3. This is not the equation that involves such type of derivative does not qualify to be a linear differential equation. Similarly, dy by dx whole raised to the power 2, etc. So such equation that involves these type of derivatives is not a linear differential equation. Number 3, the main property is that there is no product of a unknown function with the derivatives. No product of unknown function with its derivatives. So what is not allowed is y dy by dx, or for example y square d cube y by dx cube, etc. These are not allowed. So what could be the examples that are linear differential equations? These are x square d square y by dx square plus 9x dy by dx plus 5y is equal to x cube. This is a linear differential equation. Similarly, d cube y by dx cube plus 9x square d square y by dx square is equal to minus 8y. Number 3, cos x dy by dx plus 5y is equal to 3x square. This is also a linear differential equation and its order is 1. So this equation is first order linear differential equation. So what are not linear differential equations? These are cos x dy by dx plus 5. Instead of y, if we write y square is equal to 3x square. This is not linear. What is the reason of non-linearity? Is y square. The reason of non-linearity is the non-linearity of y. Similarly, as another example, if I write cos x dy by dx whole raised to the power 2 plus 5y is equal to 3x square. What is the reason of nonlinearity? Obviously the higher power of the derivative. So this term is creating the nonlinearity in this differential equation. Similarly, if you write y dy by dx plus 5y is equal to x, this is nonlinear because there is a product of unknown function with its derivative. So hopefully you may have understood the linearity of the differential equation. In this chapter we are going to deal with the first order differential equations. So let me make a general form for the first order differential equations. Example number 6 is the nonlinear first order differential equation, and this equation can be written as y dy by dx plus 5y minus x is equal to 0. The left hand side of this equation can be thought of as a function. Let the function be capital F, and it is the function of independent variable x, the dependent variable y, and the derivative of dependent variable with respect to the independent variable. So f is the function of x, y, and dy by dx, and dy by dx can be written as y prime only is equal to 0. So this is the general form of first order differential equation, and it is applicable for both linear and non-linear first order ordinary differential equations. The next concept is the concept of solution of first order differential equation. Whenever we are going to solve a differential equation, then it means that we are going to find the value of the unknown function. Since the unknown function is the function of independent variable, that we call the solution as h of x. So we have assumed that y is equal to h of x is the solution of the differential equation f of x, y, and y prime is equal to 0. So this quantity is the solution of this differential equation. It qualifies to be the solution of the differential equation if, number 1, this function y is equal to h of x is defined in some open interval. So y is equal to h of x is defined on an open interval from a to b. It means that a is less than x and x is less than b. That means that the values of y, the values of x lie between a and b. And number 2, the first derivative of y with respect to x exists throughout this interval. That means that the first derivative of y exists at each and every point of the given interval a to b. So y prime exists throughout a to b. The third and important condition is that y is equal to h of x satisfies the differential equation. And the differential equation is first order differential equation x, f of x, y, and y prime. The third property means that whenever we put this function back into this differential equation, then we have an identity in this equation. This means that left hand side comes out to be equal to the right hand side. So now we will verify that the given function is the solution of the given differential equation. Let we take the first example. Example number 1. Verification of the solution. Let y is equal to h of x. Let it be c divided by x, where c is a constant. You have to prove that this function y is equal to c divided by x is the solution of the differential equation x y prime is equal to y is equal to minus y. So let me solve it. This is a very simple and basic problem. Since there is involvement of the first order derivative in the given equation, let we call it the equation number 1. Since y is equal to c divided by x, therefore y prime is equal to, you must be familiar with the derivatives, minus c divided by x square. Now you have to put these values in the given equation number 1. You get x multiplied with y prime, that is minus c divided by x square, is equal to minus y, and the value of y is c divided by x. And here we get minus c divided by x is equal to minus c divided by x. It means that the identity holds here. It means that left hand side is equal to right hand side, and thus the given function is the solution of the given differential equation 1. Similarly, you have to prove that in example number 2, you have to prove that y is equal to sin x plus c is the solution of y prime is equal to cos x. So this is a very simple question. Y prime, you can find out the value of y prime from here. Take the derivative on both sides. Y prime is equal to the derivative of sin x is cos x, plus, since this is the constant c and its derivative is 0, so we have gotten the given partial differential equation. The next example is quite important. And in this equation you have to verify that, example number 3, in this example you have to verify that y is equal to a cos pi x plus b sin pi x is the solution of y double prime plus pi square y is equal to 0. So all the first you have to find out the first derivative, y prime, and y prime is equal to the derivative of a cos pi x, which is equal to minus a pi sin pi x plus b pi cos pi x, and the second derivative is minus a pi square cos pi x plus b pi square, and the derivative of cos x is minus sin x, and we will write a minus here. You have to just put these values into the differential equation number 1. The left hand side is y double prime. The value of y double prime is minus a pi square cos pi x and minus b pi square sin pi x. There is a mistake. And the next quantity is plus pi square and y. What is the value of y? A cos pi x plus b sin pi x. A cos pi x plus b sin pi x. So this is the left hand side. Simplify it. Minus a pi square cos pi x minus b pi square sin pi x, and apply the distributive law here, plus a pi square cos pi x and plus b pi square sin pi x. We can notice that this gets cancelled with this, since they are additive inverses of each other, and similarly this gets cancelled with this one, and we are left with 0 because all of the terms are cancelled with each other, and this is equal to right hand side. Thus the given function is the solution of given ordinary differential equation. As a homework assignment, I have a question for you. You have just to prove that you have to show that y is equal to minus sin x plus ax square plus bx plus c. This is the solution of y triple prime is equal to cos x. You have to take the derivative of y 3 times. You have to find out the third order derivative of y. And this is your homework. Hopefully you have fully understood in this lecture number 1. This completes the lecture number 1. In the next section we will learn the modeling of the first order differential equations. Thanks for watching.